In this short lecture, I'm going to talk about the searching algorithms. There are two types of searching algorithms, the linear search and the binary search. So in the linear search, we start at the first element and we check each of them. We just work our way along. So if we have a list of numbers, we go, I want to find the number 7. And I just move along saying, is that the number 7? No. Is that the number 7? No. Is that the number 7? No. Is that? And keep going. That is a linear search algorithm. So here we're looking for the number 19 and we want to go to our list. So we start at the first one. So we start at the first. 2, is that 19? No. Is that 19? No. Is that 19? No. And you keep on going until you hit 19 and then you stop. Now, if 19 was at the end of the list, you'd have to search the whole list. It's just a simple while loop that checks and checks and checks. It's very easy to understand. You just walk along asking, are you 19? Are you 19? Are you 19? The list does not have to be sorted, which is great. It's okay for small lists, but when your lists get longer, it is very, very, very slow. But this is a big pro here is lists do not have to be sorted. The better one is the binary search. So in this one, you have to have a sorted list. And so what happens is you're given a sorted list and you're asked to find a number. And what you do is you go, get me to the middle of the list. Is my number greater or less than the number I'm interested in? If it's less than, then you know it's on the left side of the list. If it's greater than, it's on the right side. And so you split, for example, the right side. You only have half the list now. And then you go, okay, let's find the midpoint of this half list and see is my number. And if my number is in that part, and you keep on narrowing down further and further. Divide and divide again and divide again. So here's our example. Find the number 19. So the midpoint, which is the 10th element, which is 29. Is 19 less than 29? It is. So that means 19 must be in the left side. Then we find the midpoint of the left side, the 5th element. Is 19 bigger than that? Yes. So therefore, 19 must be in that small section there. And we keep on going down further and further. And we stop here because actually in this scenario, we get to the midpoint, it is 19, so we found the value. Yeah. And so that once again is a while loop, but every time you get a new midpoint. Yeah. And you go until your midpoint, the value at your midpoint is either the value you're looking for or you split again. That's it. And what's the order of growth? This links nicely with the merge sort and quick sort. It's of order n. So if you have one number, it's immediate. If you have two numbers, you just go one side or the other. If you have 4 numbers, it takes 2 splits. 8 numbers, 3, 32, and so forth. So it's log to the base 2 of n. So if you have 2 million numbers, it only actually takes 21 splits to get the number you want. And that's amazingly quick. So it's very effective. It's very good for large lists, but it only works on sorted lists. So if you're only looking for a number once, you can use linear sort and you don't have to sort your list. But if you're going to do this again and again and again, sort your list and then use the binary search. So the question is how many times you want to search and when you want to use it. Once again, what is the best algorithm? The best algorithm is the one that is best for the task you're interested in. So that is it. There are the two simple sorting algorithms, linear and binary search.